Hi, Algebra 2. This is Unit 4, Lesson 11b, and we're going to continue to solve exponential equations today. We're going to use logarithms. So we learned earlier how to solve exponential equations if we use the method of common bases. That, however, is extremely limited because sometimes it's just not possible to get the same base. So we're going to use the power rule that we learned earlier, and that's if I have log base b of a to the x, that exponent comes out in front. So log base b of a to the x actually equals x times log base b of a. So let us remind you how to do that method of common bases. So say I have 4 to the x equals 8. We're going to solve it with common bases, and then we're going to solve it with logarithms on the other side. So I want to write this 4 to the x as a common base. So 4 is really 2 squared. And 8 is really 2 to the third. And once I have the same bases, then I'm allowed to just set those exponents equal to each other. So I get 2x equals 3, x equals 3 divided by 2. Okay, so that's a common base. Sometimes I can't get a common base though. So here's how I do it. Again, I have 4 to the x equals 8. What I'm going to do is I'm going to take the log of each side. Okay, and then I'm going to use that power rule. This x is going to come out in front. And now I'm going to just solve for x by dividing by the log of 4. Okay, and I'm going to do log of 8 divided by log of 4 on my calculator. And you're going to see we're going to get the same exact answer. So log of 8 divided by log of 4. And I get 1.5, which is at 3/2. Okay. And x equals 1.5. So basically what happens when I'm solving using logarithms is I get that x out of the exponential by bringing it out in front. So I take the log of each side and that x comes out in front, and I'm just solving to get x by itself. So when you're doing this, I have a couple of rules listed here. You have to isolate the exponential expression. Sometimes there's going to be other stuff on the same side, and I got to get rid of that stuff. So isolate the exponential expression, take the log of both sides, bring that exponent in front of the log, and then I solve for the variable. All right, so the beauty of this logarithm law is that it removes a variable from the exponent, which is what we want. And this law in combination with the logarithm base 10, or the common log, allows us to solve almost any exponential equation using a calculator. So let's try it. So I'm going to take the log of both sides. Log 5 to the x equals log of 18. The x is going to come out in front. And then I'm going to solve for x by getting rid of that log of 5. Whatever I do to one side, I have to do to the other side. So in your calculator, you're going to do log of 18 divided by log of 5. Log of 18 divided by log of 5. And I get 1.79. I'm going to round that off to 1.80. All right, so I'm going to have x equals 1.795, but I'm going to make it 1.80. And you can just do a little check just to show you that this is actually right. So 5 to the 1.8, okay, is about 18. So you can do that in your calculator to check it out. All right, so B, take the log of both sides. Bring that exponent in front. And to get x by itself, I'm going to do log of 100 divided by log of 4. And do that in your calculator. Log of 100 divided by log of 4. Log of 100 divided by log of 4. And I get 3.32. This says to round my answers to nearest hundredths. 3.32. Okay, 3.32. And next up, take the log of both sides. I want you to get comfortable with this before we start making them a little bit more complicated. The x comes out in front. And then I no longer have the x as an exponent. I just want to divide by log of 2. So log of 1,560 divided by log of 2. Log of 1,560 divided by, divided by log of 2. Nearest hundredth, 10.61. All right, next page. Let's make them a little bit harder here. These equations can become more complicated, but basically you're just using that logarithm law. So I'm going to have log of 6 to the x plus 3 equals log of 50. The x plus 3 comes out in front. And then I am trying to get x by itself. I'll divide by log of 6. So I have x plus 3 equals, I'm going to do log of 50 divided by log of 6. Log of 50 divided by log of 6. And I get 2.18. 2.183. Okay, 2.183, 2.183. Now I have to get x by itself, so I have an extra step. I still don't have x by itself. I'm going to have to subtract 3. Okay, so x equals negative 0.82. Okay, so you can see I'm making them a little bit more complicated. Do the same thing though, taking the log of both sides. This says x over 2 minus 5. That's going to come out in front. X over 2 minus 5 times log of 1.03. So x over 2 minus 5 equals log of 2 over log of 1.03. Okay, so I took the log of each side. I took this whole exponent and I moved it out in front just so you can see what happened. I'm trying to get rid of, I want all the logs on one side, so I divided by log of 1.03. Log of 2 divided by log of 1.03. You're using a calculator, so who really cares how big or, these get. Log of 2 divided by log of 1.03. And that gives me 23.4497. 23.4497. So that is x over 2 minus 5 equals 23.4497. Now I still got to solve for x, so I'm going to add 5. So that's going to be x over 2 equals 28.4497. And I have to get x by itself. I'm going to multiply by 2. Multiply this whole thing by 2. So I actually get x equals 56.899. Notice I kept a lot of these digits to the end. I want to round my answer to the nearest hundredth, but I don't want to do that until the end. Okay? All right. Let's switch to another color because it's sort of running into that next problem. Now, here's what I was talking about when I said I have to isolate the exponential expression. I have 5 to the 2x plus 9 equals 40. I have to get rid of this 9 before I start taking the log of anything. I want to isolate that exponential expression. Once I just have an exponent, now I'm going to take the log of both sides. So the log of 5 to the 2x equals the log of 31. The 2x will come out in front. And to get x by itself, I'm going to divide by log of 5. So log of 31 divided by log of 5. Log of 31 divided by log of 5 is 2.1336. So I got 2x equals 2.1336. And I got to get x by itself. So there's an extra step. And I still don't have x by itself. I got to divide by 2. And I get 1.07. Same thing with d. I have to isolate that exponential. So I'm going to add 5. So I have 3 times 2 to the x equals 25. I just added 5 to both sides. I still have to isolate this. I got to divide by 3. I don't have it by itself yet. I'm not going to do anything till I have it by itself. Now I have it by itself. 2 to the x equals 25 over 3. Looks yucky, but who cares? Just take the log of both sides. Log of 2 to the x equals log of 25 over 3. The x comes out in front. You're going to do this in the calculator, so it doesn't matter that it's a fraction. I'm going to divide it by log of 2, divided by log of 2. So basically I have log of 25 over 3 divided by log of 2. All right, let's see what that looks like. So log of 25 divided by 3 divided by log of 2. And I get 3.058. I want it to the nearest hundredth. 3.06. Okay. And I'm going to skip this one. All right. But I do have to remind us of this when we worked with this formula back a couple lessons ago. It was probably a week or two ago now. A equals P times 1 plus or minus R to the T. So we're going to take the problems, those percentage problems that I worked on, but now I'm going to be able to solve some that I couldn't solve before because now I know how to do logs. All right, so I'm going to take that and I'm going to put that at the top of my paper right here so I have it to look at. All right, so let's look. A biologist is modeling the population of bats on a tropical island. When he first stops observing them, there are 104 bats. The biologist believes that the bat population is growing at a rate of 3% per year. Write an equation for the number of bats as a function of the number of years, t, since the biologist started observing them. Okay, so let's do B of t. It's P, that's 104, that's the principal. 1, this is increasing, so 1 plus. The rate is 3%, so it's going to be 0.03 to the t. So we did that back a while ago. Now the problem is that's all we basically did. I want to solve for t. I want to solve for the number of years. Using your equation from part A, algebraically determine the number of years it will take for the bat population to reach 200. So my bat population is going to reach 200, and I'm going to solve this to figure out how many years it will take to do that. Now I'm going to take that 1 plus 0.03, and I'm going to write it as 1.03. All right, I'm solving for t. I'm solving for the exponent. Let's isolate this exponent. So I'm going to divide by 104. All right, and once it's isolated, I'm going to take the log of both sides. So I'm going to have the log of 200 over 104 equals the log of 1.03 to the t. The t will come out in front. Let me just write this on the other side. So it's t times log of 1.03. And to solve for t, I'm just going to divide by log of 1.03. So I have log of 200 divided by 104 divided by log of 1.03. All right, so log of 200 divided by 104 divided by log of 1.03. and that will give me my t. So it's going to take about 22 years for that bat population to reach 200. So I can take those problems that I was doing back in the beginning of the chapter, but now I can do a little bit more with them. So let's look at another one. A stock has been declining, all right, in price at a steady pace of 5% per week. If the stock started at a price of $22.50 per share, determine algebraically the number of weeks it will take for the price to reach $10. Round your answer to the nearest week. All right, so 10, because that's the price that I'm going to reach. It's starting at $22.50. That's my P. 1 minus 0.05 because it's decreasing, and I'm solving for W. All right, so I need to isolate this exponential. I want to isolate this right here. So I have to get rid of the 2250 by dividing it. And then I'm just going to take the log of each side. So I'm running out of room. I'm going to do it over here. I'm going to take the log of 10 over 2250 equals the log of 1 minus 0.05 is the log of 0.95. That W will come out in front. And then I'm going to divide by the, oops, that should be 9. I'm going to divide by the log of 0.95. So that will give me my W by itself. So the log of 10 divided by 2250 divided by log of 0.95. And that will tell me how many weeks it will take to solve that. Or for the stock to reach that price, rather. So log of 10 divided by 22.5 divided by log of 0.95. And it's going to take me 15.8, so about 16 weeks